So before going deep in the case study we have, which is the Atlantis project, I will briefly introduce you our company, and then at the end we will have a slot for where I will try to reply to your questions. I want just to remind you that you can pose your question in the Q&A tab you have on your right. So ADP New, born in 2015 as a joint venture between EDP, a Portuguese utility with a strong presence all around the world, and its Chinese shareholder CTG, mainly to focus on R&D projects in the energy field and to help and sustain both companies in the energy transition. Our mission in EDP New is to create value for the entire group by adopting a cross-sectoral approach and trying to create added value for the organization. We also aims to be at the forefront as an R&D center in projects related to energy. So in EDP New, we are divided in 6 areas, main areas. We have the business development, which is a cross-cutting area that oversees the other 5 ones and ensures financial control and planning, and support the entire organization, also seeking for new investment opportunities. And then we have other 5 technical areas, which covers the main pillars for an energy utilities, such as ourselves. We have the smart energy system areas, which develops and study smart grid solutions to sustain local communities and energy systems. But they also investigate on electric vehicles and their impact on the grid and integration. And one key point they focus on is the interoperability between the different actors that composes an energy system, such as DSO, consumer, prosumer, by studying, for instance, new approaches like peer-to-peer transactions. So paving the way towards the energy market of the future. Then we have the positive energy communities, whose main area of expertise is about smart cities and buildings, and also mitigation of energy poverty. Then there is the RES technologies area, which is the one I belong to, that focus on onshore and offshore wind plants, energy, and PV system, with particular focus on the O&M side. Then we have the RES integration and flexibility, which basically studies the impact in the integration of renewables technologies on the electric system. And also a hot topic of the moment, which is the production, transmission, distribution, and use of hydrogen, with particular emphasis on green hydrogen solutions. And finally, we have the digital area, digital energy area, which deals with big data and data analytics for the energy sectors, cybersecurities, AI, machine learning algorithms, and other topics. So our center is a multicultural group comprising more than 40 researchers with different backgrounds, and currently we have more than 31 projects in our portfolio, either starting or going or concluded. In these slides, I have reported just a few of the ongoing projects we have about wind energy. The first one, Pivot Boy, it's a really ambitious project that focuses on the design, dimension, and development of a new concept for floating offshore winds that might reduce the LCOE up to 50%. Our role in the project is to bring the end user perspective, leading the LCOE assessment and the exploitation plan. Then we have Durable, which focus on the reduction of the O&M cost for wind and PV systems by adopting innovative technologies and leveraging from the knowledge coming from other sectors, such as aerospace and robotics. Here in this project, we will lead the demonstration campaign in our PV power plant. And then there is Smart4Res, which aims to enhance the forecast of renewables energy by proposing new models. In this project, besides defining system requirements and specs, we also develop such kind of models for the forecast. And finally, we have Area 2, which aims to develop new resource assessment tool and O&M strategies to support wind farm developers and operators. And the solution developed within this project will be tested by the WindFloat Atlantic O&M team. So the topic of this session is about robotics for O&M in offshore wind. So robots can be really a game changer for O&M in offshore wind, bringing several benefits that might foster the growth of this sector. In fact, as we all have been witnessing in the last years, offshore wind has been the fastest growing source in the world globally, to the point that the additional 5 terawatt are expected to be installed by 2030. So furthermore, in the last years, offshore wind installation have been moving farther from the shore thanks to the development and progress of floating structure, and have increased in size. So these two aspects combined together will lead to an increase of complexity for the O&M activities, with a consequent increase of their cost. Nowadays, we can say that O&M weighs approximately for 25% of the LCOE. So this will lead to an increase of this percentage. So in this sense, it's paramount to adopt new solutions and integrate cutting-edge technologies to lower this cost and improve the maintenance of these assets. And among several technologies, robots and AI can be a game changer. In fact, autonomous operation can foster predictive and preventive maintenance and reduce downtime and thus the cost of this operation. And beside this, they can also de-risk this operation, which are really risky because they are conducted in a really harsh environment. And that's the goal of the Atlantis project. So now talking about Atlantis. The Atlantis project aims to establish new frontiers for inspection and maintenance of offshore energy infrastructure. And this objective will be reached through a two-step demonstration campaign in the coastal testbed and in the offshore testbed. The coastal testbed will offer a pioneer pilot infrastructure capable of demonstrating key enabling robotic technologies for the inspection and maintenance of offshore wind farms. These large pilots will be operated and demonstrated by a strong collaboration between R&D communities and industrial energy ecosystem. Then the other step of the demo campaign will be conducted in a real offshore wind farm, the WindFloat Atlantic, owned by Ocean Winds, of which EDP Renewables is part of. The Atlantis project is a 3 years project that embraces 10 different partners coming from 6 different European countries. The overall budget is around 8.5 million euros, of which almost 500 grants are designated to EDP. In Atlantis, our role will be to play. In Atlantis, we will be playing the role of the end user by defining the system requirements, meaning what the robot should do and how they should do it. But we will also lead the demo campaign by offering the pilot, the WindFloat Atlantic, and we will study the impact of the Atlantis solution on the OPEX and LCOE of this technology. So here in the picture of on the left, we have the Atlantis Test Center, which is composed by the coastal testbed and the offshore testbed. But beside these two testbeds, also a shore control center will be deployed, in which human operators could supervise, assist, and monitor the autonomous operation, and eventually take control of the autonomous robots in case of emergency. The Atlantis Approach articulates over 4 different steps. So firstly, R&D institution, technology providers, and end user have defined the specification and requirements for the robotics technologies. Then, based on this, technologies developers have designed and constructed their solutions that we will be firstly testing in the coastal testbed and then subsequently in the offshore testbed. And finally, the robotic technologies that turn out to be operating and suitable for this kind of environment will be rolled out in the market. Here we have the timeline of the project. So the project was kicked off in the January 2020, and in the first year of the project, we have defined the specification of the showcases, meaning of the kind of intervention and IMR tasks that we want to tackle. And now currently we are in the development phase in which technology providers are developing and designing their solutions. But at the same time, we have started the design phase of the coastal testbed. Then in May 22, we will start the demonstration campaign, firstly in the coastal testbed and a few months later in the offshore testbed. So Atlantis tackles 4 different showcases, representative of a typical offshore wind farm. During the first year of the project, Atlantis end users, such as ourselves, have screened the industry requirements and specification to shape the different robotic technologies. So the first showcase focus on the inspection and maintenance of turbine, of the wind turbine generator, meaning blades and tower, and on the floating structure or fixed structure according to the type of offshore wind farm. Then the second showcase relates to export and array cables. It addresses 2 main topics. The first one is the inspection of underwater cables protection systems, and the second one is about underwater monitoring over extended time of periods. The third showcase is about foundation and scour protection. It encompasses mainly 2 tasks: the close-range inspection of foundation, meaning mooring systems, for instance, in the case of floating wind, and underwater monitoring of scour protection. Finally, the last showcase is about offshore logistics, and it outlines the equipment needed for the O&M task and establish a new framework for the optimization of the robotic fleets. So, talking about the first showcase, which is about the wind turbine generator, in Atlantis we are shaping a new way to conduct this inspection. So basically, this will be performed by an autonomous drones that will be transported to the structure through an autonomous surface vessel. So the drones will autonomously take off from the surface vehicle, and by following a pre-planned route, it will inspect the 3 blades and the tower. Then they will send this information to the Shore Control Center for post-mission analysis. Once the inspection is over, it will autonomously land over the ASB, and it will be ready to either to inspect the next turbines or to go back to the Shore Control Center. So, as said, all the information collected will be processed by Atlantis, the Atlantis, let's say, data analytics layer, which is basically a predictive tool that will support technician in the post-mission analysis. So about this showcase, we have conducted a desk study in which we have basically compared conventional methodologies, which entails the involvement of rope access technician against the Atlantis method. And we have noticed that thanks to Atlantis solution, we can increase the accessibility to the site to carry out this kind of task by almost 50%. And also we noticed that this increase is not linear in the month. In particular, is higher in cold months, in which we almost double the number of available weather window. And this is a great result, since in cold months we have a higher probability of failure for the wind turbines. So we can increase the promptness of our intervention, thus reducing downtime. The second showcase, which is about the floating structure, encompasses different robotics solutions. The main tasks that will be performed under this showcase are NDT measurements and cleaning of the surface. So basically, is equipped with visual cameras, multi-beam sonar, and cleaning tools can be used to clean, inspect, perform NDT tests on the structure to test its stability and mechanical properties. Or ASVs, autonomous surveys vessel, can be deployed to carry out mapping and visual inspection of the transition phase, also known as splash zone, to assess the marine growth thickness and the status of the cathodic protection system. Finally, an intervention AUV can be used to perform cleaning of the structure and NDT measurements. This AUV will have hovering capabilities, and it will be equipped with a couple of manipulators and cleaning tools like a rotating brush. For what concerns the inspection and maintenance of power cables and cable protection system, in Atlantis we are foreseen to use ROVs and AUV. So for instance, an AUV can be launched from a support vessel, which can be either manned or unmanned, and it will navigate across, towards the area to be spotted. Here he will collect visual and acoustic information from the underwater environment and will send this map to the shore control center. Moreover, it will be endowed with control algorithms to autonomously inspect the seabeds and to avoid collision with obstacles and other structures. For what concerns cleaning and close inspection, instead we are foreseen to use an hybrid ROV, which will allow to record video of specific components of the CPS, like A-tube, bend stiffeners, Uraduct, buoyancy modules, and so on. Moreover, this hybrid ROV will be equipped with cleaning tool like water jet or brush to remove soft marine growth. So, as I mentioned earlier, a key innovation introduced by Atlantis is the monitoring of the offshore wind farm components over an extended time of period. And this can be done by adopting an innovative solution, which entails the use of an AUV with a docking station. This combination will allow to monitor and inspect the different components more frequently. So basically, here the docking station will have a twofold role. First, it will provide a charging station for the AUV, but also a communication link with the shore control center through satellite communication. So the AUV, once started and completed the mission, will dock into the docking station, where it will be charged for the next mission, and it will transfer all the collected data. The mission can be launched and supervised by a trained technician directly from the shore control center. So there is no need to have human beings in the site. For what concerns scar monitoring, this instead will be done through an SABs that will perform a bathymetry survey uh, by means of multi-beam sonar. Um, this mission might be complemented by a close-range inspection from the AUV if we have low-quality data or if we need to grasp more information. So, to conclude, the Atlantic Coastal Testbed will be a cornerstone to test new technologies, providing a less risky and safer framework to experiment new prototypes for SMEs and industrial partners at zero cost. The design of this infrastructure will be finalized in the next month, and its deployment is foreseen for the second half of 2022. Moreover, robotic technologies, meaning drones, AUVs, ASBs, and robots, will be tested in the four identified scenarios, and their ability to overcome the current challenges will be validated. This will ensure to have replicability and adaptability of this solution, and will allow us to establish new standardized O&M practices. Then, in Atlantis, we have a multidisciplinary consortium that will promote a leading offshore wind hub, fostering collaboration between the different stakeholders, and thus minimizing, bridging the technology world with the industry world. And this will mean that we will be able to fulfill the end user expectation and needs. Finally, a long-term strategy and technology roadmap will be drafted to outline which are the Atlantis benefits and uh, the capability of Atlantis solution to overcome the current challenges and bottlenecks. So basically, that's what I had for today.